Hello and welcome to a new Algebra 1 video. This is lesson 6 and is either our last lesson for unit 1 or I may do one more just for those that are interested in seeing some of the real-world applications of solving linear equations. But let's go ahead and look at this one. We are going to solve linear equations with fractions and decimals, and look, none of us want to be here doing this. Well, except for maybe that, that one kid. But we got to learn how to deal with it, because believe it or not, fractions and decimals are more often the norm in the real world than whole numbers. Just go in your house somewhere and measure like any piece of furniture, and you will be surprised at how hard it is to find furniture that is actually like a whole number length. I mean, at least I'm shocked every time I try to measure and find this out. So if you'd like to follow along, I have a notes page you can download, and that'll make it easier so you don't have to write down all the examples. And let's go ahead and get started with a warm-up. Alright, we've got a warm-up here, and this is gonna just kind of refresh our memories a little bit about fractions and decimals, because you know what, maybe you haven't had to do a lot with fractions and decimals recently. So we need to warm up. So pause the video and try these on your own, and if you have any trouble whatsoever, start up the video because I will walk us through them. Okay, I assume you're back now. We're going to look at this first one, which is adding three fractions together. What we need when we add fractions together is common denominators, and that can be easy to forget. We might just get confused about the rules, but we need a common denominator. Since we've got three fractions here, we're going to go ahead and try to get a common denominator for all of them. And so what we do is we say 5, 10, and 2. Is there a number that I can turn all three of these into? Or even better, is one of these a number that has the other two as a part of it? So 10 actually has a 5 and a 2 in it, which means that we could make all of these have a 10 on bottom really easily. The next best choice would be 20, if you didn't realize 10 would work. So to get all of these to have 10 on bottom, we think about what do I multiply by to get a 10. So for 5, I need to multiply by 2. And since I'm going to multiply by it on the bottom, I have to multiply it on top as well, because that gives me an equivalent fraction. So this one's going to turn into 4 over 10. 3 over 10 already has 10 on bottom, so it's good. And then we think, okay, what do I need to do to a half? I want it to have 10 on bottom. That's not what I meant to write. I want it to have 10 on bottom, so to do that I need to multiply by 5, because 2 times 5 makes 10. 2 to the top and the bottom, and so that changes it to 5 over 10. Now we're going to add these three numerators together. So 4 plus 3 is 7, and 7 plus 5 is 12. So we get 12 over 10. There are two things that we can do to our fraction answers some of the time. We can't even always do it, but we should always check to see if we can do it. One of them is to reduce the numbers to the simplest numbers we can get. Simplest meaning smallest. So 12 over 10, they're both even. They're both divisible by 2. So we're going to divide them both by 2 and get 6 over 5. That is an absolute must of a step. You need to always be looking for, can I divide them both by 2? Can I divide them both by 3? Until you get something that doesn't have anything in common. The other thing you can do that you can check for is we can change this to a mixed number. Although starting in Algebra 1, you are not really required to change things to mixed numbers unless your teacher specifies otherwise. So if you immediately went to this, you may have even done that actually before you reduced. But if this was like your immediate go-to answer, that's great. It is super helpful to know how to get mixed numbers out of improper fractions. But starting now, we kind of are like, yeah, improper fractions aren't so bad actually. They're easier to work with a lot of the time, so we just kind of leave them unless we have a reason not to. So 6/5 or 1 1/5 is our answer here. Well, let's look at number 2 down here. How do we divide fractions? So we do 4 over 7, and then we switch it to multiplication. I've heard like a catchy phrase like keep switch flip. So we keep the 4/7, we switch it to multiplication, and we flip the 1 over 14. We get its reciprocal, and then that lets us multiply these together. When we are multiplying fractions together, we can check for things to cancel before we multiply them, because I don't really want to do 4 times 14 if I can avoid it. And if I notice that 7 and 14 are both divisible by 7, then I can cross them out. And then I've got 4 times 2 on top and 1 times 1 on bottom, which is 8 over 1. Now, you do need to write 8 over 1 as 8, because that's just, it's silly to leave it as over 1 whenever it doesn't have to be over 1. That's different than the idea of us changing things to mixed numbers. We do simplify things like 8 over 1, 8 over 2, things that divide evenly, we do go ahead and do that. How about if we are adding decimals together? So the important thing is to line up the decimal. So this 0.1, we line up the decimal, and it might help us if we go ahead and put a 0 there at the end as a placeholder. And then we've got 0.24, and then we add in our columns. So 5 plus 0 plus 4 is 9, 3 plus 1 plus 2 is 6, so this is our answer. And then when we're multiplying, we take the longer number, it doesn't necessarily mean it's bigger, but the longer number, and put it on top, and then we take the shorter number, put it on bottom. These zeros at the front that I keep writing, we do not have to write, and whenever I was a student, I did not bother writing them, honestly, but I like to write them now because I think it makes the decimals look nicer. But we don't need to multiply with those zeros. We just need to do basically 5 times 17 here. So 5 times 7 is 35, and 5 times 1 is 5, plus 3 is 8. Then we look at how many decimal places there were, because that's how many our answers need. And we look at, we add up the decimal places. So there's 2 decimal places here, and there's 1 here. So our answer needs 3. So we have to add a 0 so that we have 1, 2, 3 places. So our answer is 0.085. Now, I'm doing this. You know already that this is going to be solving equations with fractions and decimals. So at this point, you may be worried because maybe this did not go smoothly for you as a warm-up. That's fine. That's okay. Fractions and decimals do make everything more difficult. So here's the thing. We've got 2 ways to approach these problems. Okay? One of them is just to go for it, like what we've been doing. Get the x's on both sides, get the numbers on both sides. When there's fractions, make sure you get common denominators when you need to, make sure you divide the right way. Same with decimals, make sure you add correctly, make sure you divide correctly, okay? But there's another way to do it. Okay, the other way to do it is to get rid of the fractions or decimals as your first step. And it almost feels like it's cheating the system, right? Like, the whole point is that these have fractions or decimals in them, and you're saying get rid of them. Now, there is a correct way to get rid of them. You can't just just erase them or something. But that is likely to be the best way to do it, is just by not dealing with them. Get rid of them. You don't have to. So if you forget, you can just try to do it a normal way, where you add the things over and subtract and divide and all that. But we're going to walk through how to do this for a few examples, first for fractions, and then a few for decimals. And then I've got a practice page that you can practice this on your own to see if you've got it. Alright, so the way we're going to approach this is we are going to get a common denominator for all of the terms that we have. So whether they end up being fractions or not, actually, we're going to look at basically each of these terms. So this is a term, this is a term, this is a term, and this is a term. We're going to look at each of these terms and say what would be the best denominator to get, and then we're going to get it so that everything has the same denominator, because once everything has the same denominator, there's something super cool that we can do to make this way easier. So it looks to me, since we got 2, 4, 4, and 8, that the best denominator would be 8. The next best denominator would be 16. So keep that in mind. If you thought 16, that is the next best choice, and it's better to pick something than nothing. So I'm going to pick 8 though, because it's the smallest one that we can get. And I'm going to look at this 1/2 and say, okay, how do I turn that into an 8 on bottom? Need to multiply by 4 on the top and the bottom. So that turns that fraction into 4/8. And then I just keep going. How do I change this 4 to an 8? Times by 2. So that gives me 6/8. Same with this 4. I need to times by 2. You just got to make sure to change the top as well. That's one of the easiest mistakes to make. So 2/8x plus 7/8. So here is the amazing thing that we can do to make this easier. If they all have the same denominator, then we can just get rid of the denominator. And here's why. We could, and you can skip this explanation if you're like, I don't care why, I'm glad that we can do it. But we could, our next step could be that we have these x's, we think of them like they're on top of the fraction instead of next to it. That might help us out. And then we'd say, okay, we've got 4x plus 6 over 8 equals 2x plus 7 over 8. Well, here's the deal. If they're both over 8, then it has to be true that the tops equal each other. So that's why once we have a common denominator for everything, we're allowed to just say, hey, we don't need it anymore. So our next step is going to be to write 4x plus 6 equals 2x plus 7, and then we're going to solve like normal. There's a higher chance of these ending up being fractions just because they're harder to make work out nicely and also do all the things I wanted them to do. Also, my hope is to kind of get us used to that as being okay. If you are ever like, well, here we go, I got 2x equals 1, I divide by 2, should I write this answer as a fraction or a decimal? First thing is to look at the instructions and see if they ask you to do it as a fraction or a decimal, which these instructions just say solve, they don't ask us. Second thing to do is to say, okay, they gave me fractions, I should put my answer as a fraction. Whereas if they gave me decimals, I'd want to put my answer as a decimal. If I have whole numbers in general and then I end up with an answer that's not a whole number, then it's kind of your choice, but I think most teachers prefer that we leave them as fractions, and actually it ends up being easier to leave them as fractions even if you don't like it as much, because in order to write it as a decimal you have to divide and that can be an unpleasant experience sometimes. So if we leave it as a fraction, we don't have to do that. So our answer here is x equals 1/2. So now that you've seen it, you may be able to kind of work ahead a little bit. So I've got an example 2, and then I've got a now you try. So you might think about at least trying to predict what our common denominator is going to be, because that I think is something that we get tripped up on and makes us just not even want to start. And then go through the rest of the problem with me and see how it goes. And then try it all by yourself on the now you try. Then we'll go to the decimals. Alright, example 2. So we've got fractions. Let's think about what our best denominator would be. We have a 6, a 3, a 2, and another 3. Now we can turn all of those into 6. Now again, it may be that you didn't come up with 6. You may have come up with 12, which would work, or 18, which would work. And those are fine. You should totally do something rather than nothing, right? But 6 is the smallest denominator that we can have, which will make our numbers the easiest to work with. That's why we like the least common denominator as opposed to just any denominator. So since I want these all to be 6 on bottom, this first one is fine as 5/6. The next one, 3, on bottom, we times by 2. And that gives us 2 over 6. Now we are going to do the 1/2, so we need to times that by a 3 to get it to be 6 on the bottom. So 3/6 x. And then the 2/3 needs to be multiplied by 2 on the bottom. So that gives us 4/6. So now that everything has a 6 on bottom, we get rid of all of the denominators and say this is just 5x plus 2 equals 3x plus 4. And then we just do our cool equation solving things that we've been doing for a few lessons now. 5x minus 3x is 2x. I'm going to subtract the 2 over here and get 2. I can't believe these both ended up being whole numbers. It really is a lot harder to get whole numbers here when you're making these up. Oh wait, the first one wasn't a whole number, it was a fraction. It just was a nice fraction. Now you try. So this one is a little bit different, but I want to encourage you to pause the video and then start it back up either when you get done or when you get stuck. And if you're getting stuck, just kind of play the video a little bit at a time. Every time you get unstuck, try the problem a little bit more, and then if you get stuck again, play the video again, and so on. So pause. Welcome back. We are going to get a common denominator here, and what's different on this one that could throw you off, by the way, is that we've got a whole number here at the end. We want to start off by making that a fraction. All whole numbers can be fractions by putting them over 1, and we just don't write them as over 1 because we're lazy and because it's just not necessary. But this helps us remember that everything needs the same denominator, including our whole numbers. If you forget and just like leave the +4 as a +4, you're going to end up with the wrong answer, because the only way that our trick of dropping the denominators works is if everything has the same denominator. So I want to get a 10 on bottom of everything. 20 would be our next best choice. I'm going to take this 5 and times it by 2 on the top and the bottom, so that I get 6 over 10x. 7/10 already has a 10 on bottom, so I don't need to change it. And then this -1/2, doesn't matter that it's negative, I just need to think about how do I change this denominator. I'm going to times by 5. I do keep it negative. That still needs to be a -5 over 10. And then how do I change 4 over 1 so it has a 10 on bottom? I have to times by 10 so that I get 40 over 10. Now let's drop all of our denominators and finish. 6x minus 7 equals -5x plus 40. So I'm going to add 5x over to this side, and I'm going to add 7 over to this side, and this gives me 11x equals 47. Now this is an example of a truly terrible looking fraction in my opinion. Now you might say, hey, just like we don't judge books by their covers, we shouldn't judge fractions by their unfortunate numbers. And you know what? You're probably right. We probably shouldn't. But this is our answer, 47 over 11, because 11 does not go into 47 evenly. We could change it to a mixed number if we want to, but we don't have to. So that's our answer. Now let's figure out how to do this with decimals. Example 3. Now we're on to decimals, and it's going to be a little bit different, but also kind of the same. Let's see if you see what I mean. We have, if we look at this, each of these different terms has a single decimal place. They're all tenths places. So what we can do is we can use a power of 10 to basically move all of these decimals so that they're not going to be decimal places anymore. We're allowed to do this because of that property that we went over a few lessons ago, the multiplication property of equality, that as long as we multiply every single thing by the same number, then it is still the same like equation that we had before. So since all of these are have the tenths place, we're going to multiply by 10. So think about it. When I multiply by 10, it moves my decimal one place over. Sorry, it's going to be backwards for you, so it moves it one place over. Anyway, we move the decimal over the same amount for each to the right, and so that's going to make this be 2x, because we're multiplying this whole thing by 10, and so everything gets multiplied. This is going to turn this into a 7. Going to turn this into -3x, and this into an 8. Again, we have a higher chance of getting a fraction or decimal answer on these, although I do think I tried pretty hard to make them work out nicely. 2x plus 3x is 5x, and then I'm going to subtract the 7 over to this side, so 8 minus 7 is 1. So we're going to divide both sides by 5, and you see we do get something that does not end up being a whole number. And like what I said earlier, since these started off as decimals, we would it would be nice if we had our answer as a decimal. Like whatever they give you, whatever kind of numbers they give you, our goal should be to give them the same kind of numbers back. So what is 1/5 as a decimal? You may know that off the top of your head, or it may be that you come over to the side and do a little division real quick. And so this is why leaving as fractions is way better, because if we leave this as a fraction, it's just 1/5. Well, let's go ahead and get the decimals. So you say, okay, 5 goes into 1, nope. 5 goes into, and then we kind of ignore the decimal and say 5 goes into 10 twice, and it goes in evenly, so we're done. This was actually pretty nice, and it's 0.2. And that's our answer. Let's try another one. Okay, so in this one, we're going to get rid of the decimals again, but if we look, this last one has 2 decimal places, not 1. So if we really want to completely get rid of our decimals, we're going to have to move everything over twice, not just once. In other words, it's like we're multiplying by 100. Now, if you decided to just multiply by 10, that would actually still make this way easier than it is right now. So that is an option. And maybe that's the way you decide to go, because multiplying by 100 is going to make us have some big numbers here. So it's kind of, you pick your battles. So for this 1.7, we're going to move the decimal over to the right twice. So 1, 2, we need to put a 0. So this is 170. And then 1, 2, this is going to be 20 minus 20. 1, 2, and get 210x. And then this one and this one, minus 25. So now we're ready to solve. So I'm going to subtract 170x over here. I'm going to add 25 over here. So I have 5 equals 40x. And divide by 40. So if I simplify 5 over 40, I divide them both by 5 and get 1/8. Even though we are going to end up trying to write this as a decimal, it is easier if we have smaller numbers to work with. So it's still a good idea to do that. I'm going to put 8 into 1. If you're asking yourself, why are we doing this? Why aren't we just leaving it as 1/8? You don't have to change it, but you do want to watch out for instructions that tell you to change it, and it would be considered kind of like best practice for us to give our answer the same way that we got the question, which is decimals. 8 goes into 20 twice, minus 16. And if you're worried this is going to go on forever, 8 into 40 goes into 5 times. So our answer is 0.125. All right, now you try. So pause the video, see how far you get, start it back up when you're stuck or when you've got an answer starting now. Welcome back. We are going to multiply everything by 10, and that's because the most decimals any of these have is just 1. None of them have 2 decimals or 3 decimals or more than that. So we're going to times by 10. Now we do have a 6 here at the end that still gets multiplied by 10. We don't skip over it or anything, because then we won't have multiplied everything by 10. So 10 times 2.1 moves this over once, and we get 21x. 10 times negative 0.3 moves this over once, so we get minus 3. Then we move this over and get negative 7x, and this over gives us 60. So then I add 7x and get 28x. I add 3 and get 63. Again, because I'm looking at this, I'm like, this does not divide evenly, but if we notice something that goes into both, it is helpful to simplify. These are both divisible by 7, which isn't easy to see necessarily. This turns into 9/4, which is actually a really relatively easy thing to know what it is as a decimal. And since we're changing to a decimal, you might decide to go ahead and change to a mixed number, because maybe that's easier to work with. 2 1/4 is 2.25 as our answer. So if we didn't go through that process or know that off the top of our head, we just go over to the side and do some division like we've done in the earlier ones. Thank you for watching. I hope that you'll subscribe, like, comment, all those cool things, and I hope that you'll check out the next video whenever it drops. And I hope you have a great day and that all of your, all of your math problems get solved. Bye.